Alrighty, today we're starting annuities. We're going to do both future amount as well as present value of an annuity. So far you've done simple interest and compounding interest. Now we're going to do compounding interest with a regular payment. So for example, what if I were to put in $500 at the end of each year for 5 years, right? This is my annuity contract. I'm going to put in $500 at the end of each year for 5 years. Well, each one of these payments, there's 5 payments of $500, right? Each one of these is being compounded, right? R times 1 plus I is just equal to R over N. 1 plus R over N squared. 1 plus R over N cubed. 1 plus R over N to the fourth, or R. Okay, so each of these regular payments are experiencing compounding interest. Now, do you remember the geometric sum formula? Right? If I were to take all these payments in here, right, my first A is equal to 500, right? My R is equal to 1 point whatever I is, so it's going to be 1 plus I, whatever I is, and N is going to be number of years. Like if I were to put this into the geometric series formula, I would end up with this formula. This is the formula you have to memorize. Okay, that's the baby right there. So if I put in regular payments at the end of each month for 20 years, or at the end of each year for 10 years, or whatever it may be, how much would I make by the end of the time period when each one is earning compound interest? Do you see the difference between this one and the other one? What's the difference between this and this formula? What's the difference? Yes? Yes, so this is one payment, and this is regular payments. Regular payments. Okay, guys, can you get rid of the phone and focus? I see a lot of heads turning to the back. So let's do it. Suppose you deposit $1,000 at the end of each year for 10 years. Is this an annuity, or is this compound interest? And why is it annuity? Yes.
Because it goes on for 10 years.
And you got $1,000 being deposited at the, yeah, okay. So, right? So it looks something like this. This is the 10th year, and there's $1,000 coming in. The 9th year is $1,000 times 1 plus, what's the interest rate? 0.085 to the 1, because it's n. And then at the end of the 8th year, you have $1,000, and so on, starting at time 0. So you have all these payments coming in all the way up to the end of the 10th year, earning interest. Okay? Yeah. Oh, thank you. .0385. This isn't cooperating with me. There we go. Anyway, you get the idea, right? This is happening 10 times, down to the first year. Okay, so let's calculate how much money he would. This is a lot of interest happening here. A equals 1 plus R over N to the yn minus 1 all over R over N. I forgot the regular payment. So our regular payment is $1,000. Okay, times 1 plus 0.0385 divided by 1. There's only one compounding period per year. The number of years is 10 times 1 minus 1. It's quite the horrendous formula. 0.0385 over 1. So this is equal to, try punching that in your calculator, see what you get. It's not an easy guy to calculate. Just to give you the heads up, half a mark for this, 1 or 2 marks here, right? 1 mark for your calculation, and then your conclusion. The future value is, what do you get? Tell me. Yep. 9, 2. Don't forget, always go to 2 decimal places. And that's half a mark for your conclusion, right? Julia invests $200. Did everybody get that? Does anybody need any help with their calculators? No? Okay. Julia invests $200 into an account every month for 5 years where the interest rate is 5% per annum compounded monthly. What is the value of her investment in 5 years? How much interest did she earn? This is actually a 6-mark question, okay? A equals R, 1 plus R over N to the YN minus 1 all over R over N. So she's putting in $200 every month for 5 years. If it's every month for 5 years, what is N? Yeah. And it's 5 times 12 minus 1 all over 0.05 over 12. Tell me what you get. Just get practice calculating that. Anybody get a value? And always remember to take it to 2 decimal places, right? If this was money, you would want every cent. So you do it to 2 decimal places. So remember, half a mark, 2 marks, 1 mark, and then a mark for conclusion. She would have 13601.22 in 5 years. Now, how do we calculate the interest she earned? Interest equals the final amount minus the regular payment times the number of years times the number of compounding periods per year. So the amount is 13601.22 minus the regular payment, which is 200, times the number of years, and it's 12 times a year. And this works out to be 1601.22. So remember, the conclusion is half a mark, and calculating interest earned is 2 marks. She would earn 1601.22 in interest. Could we get rid of our cell phones, please? John plans to invest some money semi-annually. How many times is that per year? 2 times a year. Into account paying 6.8% compounded semi-annually for the next 15 years. He hopes to have $250,000. How much should he invest semi-annually? So what are we calculating here? A, PV, or R? Yeah. A equals R. Okay, so he wants $250,000. That's 250,000 equals, we don't know R, 1 plus 0.068. 2 compounding periods a year. 15 times 2, right? 15 years, all over 0.068 divided by 2. So we get 250, 123 equals R times 50.781 380,265. So R is approximately equal to 4923.06. Oh yeah, I just forgot to write that in, but this is the correct answer. Yeah, sure. So, he should deposit 4923.06. Half a mark, about 2 marks, that's a mark, half a mark. Okay? That's annuity, but we also have present value. All right. How much money do you need to invest today so you can pull out regular payments in the future? Right? How much money do you need to invest today so you can pull out regular amounts into the future? So, we add this up using the geometric series formula, and we end up with this formula. This is the formula you need to memorize. Very similar to the last one except for the numerator. So, you're lucky if your parents wish to provide you with an annuity that pays you $500 a month for 48 months.
This is on behalf of the class, because you thought you ran feeling so good today. So you got your flowers.
Oh, well, thank you.
No problem.
Aww. When did you get the flowers?
Oh, I asked my friends to get it for me.
Thank you.
No
I'm
problem.
sorry if I've been in a crabby mood. Well, thank you. Oh, they're beautiful. I like them. You're so sweet. I'll put them in water when I get home.
Okay.
Aww. See my flowers, internet people? I have to show the internet people. Thank you, Val. I really appreciate it.
No problem. You have a great night.
Okay, thank you. He is going to make a wonderful husband one day. Because every argument him and his wife have, he's going to buy them flowers, buy her flowers. Aren't you?
Yeah.
Yeah. Okay. Thank you.
No problem.
Okay. Oh, yeah. How much money do we invest today if we want to withdraw $500 48 times over the next 4 years? That's what we're looking at. Does that make sense? It's different. How much do we invest today so that this student can withdraw $500 a month for 4 years? Does that make sense? Right? So how much do we invest today? It's different from a future amount. PV equals R. 1 minus 1 plus R over N. Good. That should be a P, not a RV. I'm thinking of a recreational vehicle. We want present value. So present value equals, our regular payment is 500, 1 minus 1 plus 0.0175 monthly, 4 years, 12 times a year, all over 0.0175 divided by 12. Can I explain anything better? Do you want to know where some numbers are coming from? Yeah?
Does it say on there? It says like the power of
4 times 12?
Wait, where's the negative go?
Yeah, minus, you're right. Yeah. Yeah, hold it. There's a question there. What question number is that? about it. Check your numbers. 5, -8, -21, all the way down to -190. Think about it. I can't. Okay. Did anyone get this? Yeah. 1/2 a mark, 2 marks, 1 mark, and your conclusion. They should invest 23162.29 now. The present value, what they invest today. Guys, before I forget, do you know all the different types of N's there could be? If it's semi-annual, what does N equal? N equals 2. If it's monthly, what does N equal? If it's daily, what does N equal? If it's bi-monthly, what does N equal? No. Huh? N equals 6. If it's semi-monthly, what would N be? If it's quarterly, N equals 4. What if it's bi-weekly? Yeah, yeah, yeah. Are we good with that? Yep. Bi-monthly is once every 2 months. Is that my phone? Is that my phone? Is it? It's just an old test. Okay, ready? Shh. Shh. One more question. Excuse me, please don't make me yell out your name on internet land. John would love to have an annuity that provides him with an additional $250 per week when he retires. If at the time he retires he can get 2.8% per annum compounded weekly for 25 years, how much should he have saved up to invest at his retirement? What do you think he should invest? So is this a future value or a present value? And why is it present? Okay. How much should he have saved up? All right, good. So A equals R. I'm in the last question. Shh. Here, I better write the formula because that's the way I'm going to mark you, right? So this is 1 minus okay. He wants an additional 250, but that should be PV, right? PV equals 250 times 1 minus 1 plus 0.028, and it's 250 per week, so that's 52. for 25 years? Holy smokes. 25 times 52. That's a lot of...
1300. 1300.
Where did you get 1300 for this question?
I remember like I did like 52 times 25 one time in my life.
Oh,
I mean, he's not wrong.
really? He's right? You're right, it's 1300 times. What'd you get for an answer?
He hasn't gotten that far yet.
Oh,
You know, 1500 times 72. Just stares at his face.
Yeah, I didn't do that.
anybody get an answer?
Give me a minute.
Somebody, anybody got an answer?
1 second.
At least one person has to get this answer. Do you have it?
23. No. 200. No. 233,684.81. That's a lot of money.
Yeah. He should invest. He should invest 233,684.81 at the start of his retirement.
And then you gotta press the arrow down.
Okay? Half a mark, 2 marks, 1 mark, half a mark. Yep. Are we good? That's the last lesson in math. Yay! Last lesson in math.
Wait, this isn't ski. Before you end the video, you have to do like a
No.
outro.
Just,
Be like,
oh my god, you know.
this is signing off. Like and subscribe.
How about so long, farewell, I hate to say goodbye.
Follow your boy.
No.